Boom! What up, math nerds and mathletes? Coach Murphy here. You know what time it is? That's right. It's time to get on that math grind, right? Time to flex that math muscle. All right. So today we are going to finish off transformations. The last transformation we're going to talk about is dilations. Now, unlike the previous transformations we talked about, reflections, translations, rotations, dilations are not rigid motion transformations. So when we dilate something, we don't preserve its size and shape. We preserve its shape, but its size changes. So the image and the pre-image are not congruent figures, rather similar figures, because their shape is the same, but not their size. All right, if it sounds confusing, it's not. All right, I know you guys are hyped. You guys are jacked. I'm pumped. I cannot wait to dive into dilations. I know you guys feel the same way. So grab a pen, grab your pencil, grab a piece of paper, because all I need is my note, worksheet, calculator, pencil. Note, worksheet, calculator, pencil. Let's get on that math grind and get after dilations. All right, so as we said, dilations. Now, when we think of dilations, the first thing that probably pops into mind is when you go to the eye doctor and they put those drops in your eyes to dilate your eyes, right? And what they're doing when they dilate your eyes is they're enlarging or making your pupil bigger, right? And they also have drops they can put in at the end that dilate again that make them smaller. So a dilation is an enlargement or reduction of a figure. Okay, so it's an enlargement or reduction of a figure. Now, what are we enlarging the figure by, or what are we reducing the figure by? We're reducing it by the scale factor, okay? All right, so the scale factor, it indicates how much the figure will enlarge or reduce. Okay? We represent the scale factor by the letter K. All right, K equals scale factor. All right, and if K is greater than 1, then we have an enlargement. If K is less than 1, we have a reduction. Okay, as always, we have our rule. So we have a dilation, it'll give the scale factor, right? We have our original x and our original y. Transformation occurs, right? We take that k, that scale factor, and we multiply it by the x, and then we multiply it by the y. And that gives us our new points, right? That gives us our image. Okay, so the image is either going to be bigger or smaller than our pre-image. Let's look at some examples. Okay, so in this one it tells us triangle RST has the vertices of -5, 1, -3, 4, and 2, -1. So let's just go ahead so we can see it. Let's go ahead and graph this. So I go over 1, 2, 3, 4, 5, and I go up 1. There's my R. I go over 1, 2, 3, up 1, 2, 3, 4. There's my S, and I go over 1, 2. 1, 2, and I go down 1. All right, and there is my T. So here is my pre-image, right? Now, when we have our pre-image, we then take those points and we multiply it by the scale factor right here. And the scale factor is 2. And since 2 is greater than 1, we know that our image is going to be bigger than our pre-image, right? So it's an enlargement. So we're going to take each one of these points and multiply it by 2. Okay, so they all get multiplied by 2. So negative 5 times 2, negative 10. 1 times 2, 2. Negative 3 times 2, negative 6. 4 times 2, 8. 2 times 2, 4. And negative 1 times 2, negative 2. Now, let's go ahead and graph this, and we'll see that our image is 2 times bigger than our pre-image, right? So we have negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 1, 2, and that's our prime. Remember, the prime notation indicates that that is our image, right? Negative 6, 1, 2, 3, 4, 5, 6, and we're at 8. 1, 2, 3, 4, 5, 6, 7, 8, and that is S prime. And then we have 4, 1, 2, 3, 4, negative 2, 1, 2, and that is T prime, right? So when we graph it, we can see that our image is definitely bigger than our pre-image, right? Let's take a look at another one. All right, it says rhombus JKLM with the vertices J negative 10, 2, K negative 2, 8, L 6, 2, and M negative 2, 4, right? And the scale factor for this one is a half. So since this scale factor is less than 1, we should expect that the image will be smaller than the pre-image. Let's go ahead, just for a visual representation, let's graph our pre-image. So we got 10, negative 10, 2, 1, 2. There's J. We have 1, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's K. We have 6. 1, 2, 3, 4, 5, 6, 2, 1, 2. There's L. And then we have negative 2, 1, 2, 4, 1, 2, 3, 4. And there is M, right? We can go ahead and connect this, right? And this is our pre-image, right? So now, in order to get our image, we need to multiply each X and Y by a half. Or we can just go ahead and divide each of those by 2. Okay, so let's go ahead and do that. So we have negative 10 divided by 2, which is negative 5. 2 divided by 2 is 1. Negative 2 divided by 2 is negative 1. 8 divided by 2 is 4. 6 divided by 2 is 3. 2 divided by 2 is 1. Negative 2 divided by 2 is negative 1. And negative 4 divided by 2 is negative 2. Right? So, easiest way to do it, just divide by 2. Right? Now, let's go ahead and graph this just so we can see the reduction. So we go 1, 2, 3, 4, 5, up 1. There is our J prime. We have negative 1, 1, 2, 3, 4. There is our K prime. We have 1, 2, 3, 1. There's our L prime. And we have negative 1, negative 2. There is our M prime. Right, so indeed, our new figure, our image, is smaller. It has been reduced from our pre-image, right? And it has been done by a half, right? Not that bad, right? Pretty simple. You just take the scale factor and you multiply it by the other points, right? Now, what happens if you are given the two figures and they ask you to identify the scale factor used? Well, for scale factor, when we try to find it, is pre-image over image. I'm sorry. Image over pre-image. Okay? So let's go ahead and go back to our example. All we have to do is pick one point to look at. Okay? First off, let's look at our original figure. Now, I know that this one is our original figure because it does not have the prime notation, right? So that's our pre-image. Okay? And this is our image, right? So now you can't compare if it has a 0. You can't obviously do that. But let's look here. So we have 1, 2, right? So let's look at D and D prime, right? So D prime is 0, 2, and D is 1, 2, 3, 4, 5, 6, 0, 6, right? So from our pre-image to our image, it has gotten smaller, so it's a reduction. So we should expect our scale factor to be less than 1. So if we do image over pre-image, right, that means we have 2 over 6. We simplify that to 1 over 3. 1 over 3 represents a reduction. The pre-image does get reduced to a smaller image. Okay? Not that difficult, not that crazy. Pretty straightforward. It's a pretty straightforward concept, right? Dilations, you're making something bigger or smaller, an enlargement or a reduction. We do so by a scale factor. Your scale factor is your image over pre-image, right? If the scale factor is greater than 1, it's going to be an enlargement, okay? Meaning that the image is going to be larger than the pre-image. If the scale factor is less than 1, then it's going to be a reduction, meaning the image is going to be smaller than the pre-image. All right? If you have any questions, let me know in the comments. If not, get after it. As always, stay on that grind, man. It's been awesome. Boom, I'm out.